We're going to continue on the alternating series. Right, so theorem. If the series AN converges, then the summation of A, if the absolute value of AN converges, then the AN itself also converges. You can have like a quick, simple estimation. If you add absolute value onto something, you make the negative positives, and you make it kind of bigger, right? So the itself, it has positive, negative, or negative, it also converges. If it's all negatives, you add absolute value, it converge. The positive also converge. If you have positive negatives, the series itself with absolute value is smaller than the with absolute value. If it's all positive, it's the same. So basically, think about it like that. Okay. Alright. So if AN is absolutely convergent, what do we say? If we call AN is absolutely convergent. If the absolute value of AN, the series absolute value of AN converges. If the absolute value absolute value series of AN converges, then it is absolutely convergent. Okay, absolutely convergent. Alright. And AN is conditionally in the test, sorry, not in the test, in the homework part, you're going to see the absolutely convergent or conditionally convergent. If it's conditionally convergent, if the summation of AN converges, but the absolute value diverges. Absolute value of the series diverges. Okay. AN is conditionally convergent if AN converges but the absolute value of the series diverges. We have an example. For example, when you have negative 1 to the power n, 1 over m. This alternating series itself, alternating series, it converge because alternating series 1 over n positive negatives, and 1 over n goes to 0 and goes to infinity, and also 1 over n plus 1 is less than 1 over n. So the alternating series converges. However, if I add absolute value, what happened? If you add absolute value on this one, you got the whole series is just 1 over n. There's no negative sign positive anymore. But this one diverge. Right? So absolute value diverge. The alternating series converge. So this is what we call conditionally convergent. Okay. So we're going to look at some examples. Determine whether the series converge conditionally or absolutely or diverges. So basically we want to say if the series converges absolutely, conditionally, or the series just diverge. That's the example. First one, n from 1 to infinity, negative 1 to the power n, 2 to the power n. Okay. So normally we check the absolute value first, because absolutely convergent is stronger, okay, compared with conditionally convergent. So we check the absolutely convergent first. So sometimes if it's absolutely convergent, then we are done, because it's absolutely convergent, it's conditionally convergent for sure. So we check the absolutely convergence first, if the absolute of the series diverge, then we check this series itself. Okay, for example, this one, we check the absolute value of the series n from 1 to infinity. If I add absolute value on the series on the terms on the series to n, so if I have absolute value in the series itself, it's going to be a p series with p equals 2. No, not p series, my bad. With the geometric series, right? So n from 1 to infinity, 1/2 to the power n, and r equals 1/2 less than 1. So r is 1/2, and then this absolute series actually converge. So the series converges absolutely. Okay, makes sense, right? All right, so second one, n from 1 to infinity, n squared negative 1 to the power n plus 1. Okay, I'll give you 5 seconds. Look at it and see what it is. All right. So I'm going to call a student here. Eric, could you please tell me if this series converges absolutely, conditionally, or diverge?
It converges absolutely.
Converges absolutely. Why?
It becomes 1 over n squared.
And why is 1 over n squared converge? Why does 1 over n squared converge? Why does this series converge?
Nth term test is 0.
Nth term test is 0? No, the series. Can we use the nth term test to say if it converge or diverge? I want to say that again. Okay, because I've emphasized this property many times. Nth term test cannot tell you converge. You cannot use nth term test itself. Just the nth term test say, okay, this is series converge. Nope. But the nth term test can tell you if it diverge or not. So if it diverge, if you do the nth term test, if the nth term not equal 0, yeah, it diverge. But even the nth term equal 0, you cannot say, oh, this series converge. Okay, so never use the nth term test to test if it's use that as a evidence to say that's converge. The only thing you can use nth term test to test if it converge is the alternating series. First, the limit of n goes to infinity, an equals 0. Second, 1 over n plus n plus 1 less than equal to an. And this also have another requirement, is alternating series. Okay, so alternating series first, second, then it converge. Itself, nothing. You cannot say this is converge. Okay, so Eric, can you tell me why this converge now?
Using an integral test.
Integral test is okay, and also the easiest one is p series. P series, p equals 2, bigger than 1. Okay. So P series, we know this converge. Very good. You said your answer is perfect, right? It converges absolutely because the absolute value of the series converge. So it converges absolutely. All right. Very good. Thank you. Next one. N from 1 to infinity, negative 1 to the power n factorial. 5 seconds, and then I'm going to call a student. Okay, so I will call a student here. Do you have any volunteer? Okay, Taylor, could you please tell me if this one converge or diverge or absolutely converge?
I think this one would diverge.
You think this one diverge? Okay, so why do you think this one diverge?
Well, we can rewrite that as 1 over n, and then since the 1, we've got the 1 on then in the numerator there, so that's not going to be greater than 1, so it's going to diverge maybe.
Well, this is the 1 over n factorial. N factorial actually equals n times n minus 1 times n minus 2 times 1.
I think
You think what?
I'm not too sure then.
Okay.
I think
Lacey? Well, you have to press the button constantly when you speak. So, you think what?
if we
What happened? Did you press the button and then hold on to it when you speak? So you think it converges, like that.
factorial,
Okay. That's
if we try to differentiate the top, we can get the same thing and maybe cancel out. No.
okay. Alright, so what do we have? We can add absolute value n from 1 to infinity, negative 1 to power n factorial. This equals n from 1 to infinity 1 over n factorial. Okay, so we can compare something. 1 over n factorial and 1 over n squared. Okay, so 1 over n factorial compared with 1 over n squared. The common sense tell you which one is bigger and which one is smaller. So we can check something. 1 factorial equals 1, 2 factorial equals 2, 3 factorial equals 6, 4 factorial equals 24, 5 factorial equals 120, 6 factorial equals 720. Okay, so let's check. 1 square equals 1, 2 square equals 4, 3 square equals 9, 4 square equals 16, 5 square equals 25, 6 square equals 36. Now, can you tell me what you say? And what you say from these two patterns? Which one is smaller, which one is bigger? Lacey?
The factorial is bigger from
The factorial is bigger but with the 1 over it. Which one is bigger?
with 1 over it. It's going to be the n squared.
Yeah, 1 over n squared is bigger. But we know that both of them be for sure positive, and for 1 over n squared is bigger, not always. Okay? At some point, after 4, so for n bigger than equal to 4, any n bigger than equal to 4, 1 over n squared is bigger. And we know that n from 1 to infinity, 1 over n squared converges. Okay, we know this one converges because p series p equals 2. Now, we can tell this. You may ask me, what about 1, 2, 3? 1, 2, 1, the first term, second term, third term does not change the convergence of the series. It's just some numbers. It does not go to infinity, so it does not change that. Okay, so from n factorial to negative 1 to power n, this one converges as well. Okay, therefore, the series n from 1 to infinity, negative 1 to power n factorial. This one converges absolutely. Okay, so number 4 example, n from 1 to infinity, negative 1 to power n plus 1, n plus 3. I'll give you 10 seconds. All right, I'm going to call student here. Travis, could you please tell me if this series converge or diverge, or conditionally converge or absolutely converge?
Would this one conditionally converge?
Okay, conditionally converge. Why?
Because 1 over n, p equals 1.
Okay, so if you add, first we check the absolute value, see what happened. Absolute value of that, this equals n from 1 to infinity 1 over n. Sorry, 1 over n plus 3. Okay, 1 over n plus 3. 1 over n plus 3, this one actually is even smaller than 1 over, wait, is it smaller? Yeah, it's smaller than 1 over n. Well, we don't use that, we just use the comparison test. Compare with the 1 over n to infinity 1 over n. Since if you divide these two, okay, the limit of n goes to infinity, 1 over n plus 3 over 1 over n, this equals 1, okay. So this one diverge for sure because p series p equals 1. This one will diverge as well. They have the same degree. Constant never change anything, you know that. Okay, so is this one diverge? Then we have, since this one diverge, and then absolutely is diverge. Now we check it itself. We check it itself, negative 1 to power n plus 1, 1 over n plus 3. Well, we check it itself. This one is alternating series. Okay, to check if a alternating series converge or diverge, I will ask a student here. Bella, could you please tell me what I need to check for the alternating series?
I'm not sure. Or, can you do a limit?
Yeah, alternating series, I think I did give something in this class. Let me hear, somewhere. Alternating series, you check two things. First, I'll just take that off. First,
And that S equals 0, right?
yeah, that goes to 0. So we check this one. What you got? What I put out for an? What do I put for an here?
Negative 1 to the n plus 1.
Okay, this is the sign. The alternating series is n from 1 to infinity, negative 1 to power n a n. So you compare this. What do I put for an here?
Oh,
1.
1 over n plus 3.
Okay, so 1 over n plus 3. Now n goes to infinity. This one equals
Oh, 0.
0. Very good. Okay, alternating series, I need to check two things. The second thing, I need to check an and an plus 1. Greater than equal to or less than equal to? Greater than equal to, right? Okay, very good. Greater than equal to, what is an?
1 over n plus 3.
Okay, very good. What is the an plus 1?
1 over n plus 3 plus 1.
Very good. Okay, so which one is bigger, which one is smaller?
An plus 1 is smaller.
Very good. So this one is bigger than that. So we check the two conditions, both are okay. So which means this alternating series will diverge or converge.
Converge.
They converge. Very good. Once we satisfy nth term test and also not nth term test is not a test, just nth term goes to 0 and also the an is bigger than equal to an plus 1. Alternating series, it converges. Very good. Thank you very much. Okay. So this one converges and absolutely it diverge. Itself, it converge. So this is conditional converge. Conditional converge. In your homework, you have a lot of problems to practice about the converge or diverge series. Okay, and next example, 4, 5. N from 1 to infinity, negative 1 to power m, 2m plus 3, m plus 10. I'll give you 5 seconds. Look at this one. Okay, I will call a student here. Luke, could you please tell me what do you think about this series?
Well, when you take the absolute value, you need 2n plus 3 over n plus 10.
Okay. So
Which is gonna
it converge or diverge?
that's gonna converge to 2.
Oh,
So
so
then the original series converges.
so you say this one equals the series n equals 1 to infinity, 2m plus 3, m plus 10, right?
Yeah.
Okay. And then you say the limit of n goes to infinity to m plus 3, m plus 10, this equals 2, so this converge, right? Is that what it said? The series converge.
No, I'm sorry, I just got confused.
Okay, so now I think so far you're doing okay. You add absolute value, you got this, then what?
And then, I guess since the limit equals 2, diverge.
Diverge, perfect, okay. Alright, so you look at this when it's kind of like sometimes you just look at this real quick, it's just a quick estimation instant quickly. You can tell that the nth term. Now just look at the nth term. So even this is negative 1 to power n is okay. This is your nth term. Let's look at the nth term test. Limit n goes to infinity equals 2, and this one nth term not equal 0. The nth term must equal 0 if it converge, for sure. Okay. If the nth term equals 0, I don't know if it diverge or converge. But if the nth term not equal to 0, for sure it diverges. Okay? So we check the nth term not equal to 0. We got the whole series diverges. Okay? The series diverge. I cannot see this diverge. We got the series n from 1 infinity, negative 1 to the power n, to n plus 3, and n plus 10. Nth term equals 0. We don't know if it converge or diverge. Nth term not equal 0, for sure diverge. Okay, so next one. N squared cosine n pi. I give it 10 seconds on this one as well. Okay. I think I'm going to call a student here. Nicholas, what do you think?
So can we make the absolute value of that cosine of n over n squared?
Yeah, we can make an absolute value on that. So if I make an absolute value of cosine n pi over n squared, what I have? This equals what?
Is it cosine n over n squared?
What is cosine n pi? The question is, what is cosine n pi? You can check yourself. What is cosine pi? So, Nicholas, what is cosine pi?
I don't know.
What is cosine 180?
Is it -1?
Yes, -1. Okay. So how do you know if how do you find the cosine pi or pi? What you do, you can do a remember in a circle. This is 0 degree, pi over 2, 90 degree, and this is a pi, 3 pi over 2, and 0. So you can draw a circle, memorize it. Cosine pi is the x value. Sine pi is the y value. Any point on the circle. Any point on the circle. Okay. The x value is the cosine value, cosine, and the y value is sine. Okay. So for sure, if this is a unit circle, this is 1, 0. So which means cosine 0 equals 1, sine 0 equals 0. If it's this point, for example, at pi over 4, okay, this point is square root of 2 over 2, square root of 2 over 2. So you got cosine cosine pi over square root of 2, sine pi over 4 is square root of 2. It's easy for us to memorize the points, especially these 4 points, right? So you got this point, the coordinates is -1, 0. So I got cosine pi equals -1 and sine pi equals 0. That makes sense, right? And it's easy to at least I can memorize these 4 points for sure. And this point, the coordinates is 0, 1. So I got cosine 3 pi over 2 equals 0. The sine 0, -1. Sine 3 pi over 2 equals -1. Okay. This is how you memorize the special angles. So now I got cosine pi equals -1. Alright, so I want to ask you again, Nicholas, what is cosine 2 pi?
-2, right?
Okay, so 2 pi is going back again, right? A circle going back to this one again. 0, 2 pi, and 4 pi is here again. So go back to this circle. Is what?
Yeah, that would be 2, right?
Where did you get the 2? So cosine 2 pi is cosine 360 degree. So it's back into 0 again.
Yep, so it's 1, right?
It's 1. It's 1. Very good. Okay, a question again. What is cosine 3 pi?
1.
Cosine 3 pi.
Negative 1.
Negative 1. Very good. What is cosine 4 pi?
1.
Okay, cosine 5 pi. What's cosine 5 pi?
Negative 1.
Negative 1. Okay, what is cosine 6 pi?
1.
1. Very good. Okay, so now I got it. 1, negative 1, negative 1, positive 1. Basically, if I add an absolute value, what happened? What if I add absolute value onto this one? What is cosine n pi now?
It'll just be 1.
It just be 1. Because cosine pi negative 1 absolute value is 1. Absolute value of negative 1 is 1. So it just got negative 1 to power n. So I don't need that. If you put that as negative 1 to power n. But if you take off the absolute value, it's just the 1 over n squared. You add absolute value, right? So now, Nicholas, I continue to ask you if this series converge or diverge.
Well, it's a P series and P is greater than 1.
Okay, so it
Converges.
It converges. Very good. Perfect. You did a very good job. So now we did this one. We got this one converges. Very good. Then the whole series converges absolutely. Okay, so m from 1 to infinity, cosine n pi over n squared converges absolutely. Okay, great. I think we got enough examples so far, and you definitely have a lot of practice at your homework. And we're going to continue on next section, ratio test and root test. 9.6, the ratio test, the ratio and the root test. Okay. Let me see. The ratio test is, maybe I'll give you a little bit review since we got so many so far. Just a quick review. What do we got so far? Okay. So very quick review of everything. First, I want someone to help me continue with it. So what did we learn at the beginning, Jasper?
Beginning of series.
Yeah.
We learned about the nth term test.
Yeah, very good. Nth term test. That's the very beginning of this one. Nth term test. Okay. So we got n equals 1 to infinity, limit n not equals 0. Then the end diverges. Okay. Second, after nth term test, what we learn, Jasper?
We learned about P series.
Before P series, we have another one.
Integral test.
Before integral test, we have another one. One over 2 to power n. The ratio is 1/2.
Oh, geometric series.
Yeah, geometric series. Very good. Perfect. So before we do, after the nth term test, the next we see is geometric series. So geometric series, we did n from 1 to infinity, n to 0, ARM. So this equals, alright, so Jasper, could you please tell me what that is? N from 0 to infinity, ARN, what you got for here?
Okay, so if R is greater than 1, greater than or equal to 1, then it diverges.
Okay.
And if R is less than 1, then it equals A over 1 minus R.
Perfect. Okay. So number 3, we got after geometric series. Jasper, what do we do?
Then P series.
Then P series. Very good. So P series, what do we got? We got a something n from 1 to infinity, 1 over n to power p. So this one, can you continue?
If P is greater than 1, then it converges.
Very good. And then?
And if it's less than or equal to 1, then it diverges.
Very good. It diverges. Okay. If it's less than or equal to 1. Alright, so after the P series, what do we got?
With the integral test.
Integral test. Perfect. Integral test. So what do we have for the integral test?
Integral.
Okay. The integral test, we set up n from 1 to an. So what do we set up? An.
Set up
Right. Okay. Set up an as a function of fn. So basically, all the n is going to be x. So it's a function of fx. So integral test. What we need for the integral test? Fx must be what? Jasper?
positive.
Positive. Very good. Positive, second, fx decreasing. Really good. Very good. Okay. Positive and decreasing. So we have, how do I set up the integral here? The boundaries. From where to where?
From, in this case, would be 1 to infinity.
From 1 to infinity. Very good. And this is one from 1 to infinity, an. Both diverge or converge. Very good. Okay, so next one, we did a comparison test. Okay, Jasper, could you please tell me what the comparison test says?
Okay, so if you have one series and you compare it to another series, and if the series is smaller than the second series, then if the second series converges and the first series converges,
Okay, so I put it here 0 less than an less than equal to bn. So now use a and bn. So if
bn converges, then an converges.
very good. If
Then if an diverges, bn diverges.
very good. If an diverges, then bn diverges. Okay. So we have another thing for the comparison test. We have a limit. You can divide those two series, an, bn over an. You can divide these two, and this equals another number bigger than 0. Then no, I don't want that. Then bn, then an and bn, if they have the ratio as a constant, for example 1 over n plus 1, or 1 over n squared plus 1, like those kind of series, okay, you can divide it and you get a constant. So a and bn have the same convergence property. Okay. All right. So after the comparison test, what do we got, Jasper?
Then we have alternating series.
alternating series. Perfect. We got alternating series. So alternating series is, for example, we have n from 1 to infinity, negative 1 to power n a n. Okay. So we have two conditions. Can you tell me what the two conditions are?
If the limit as n approaches infinity of a of n equals to 0,
And second,
and then if a of n is greater than or equal to a of n plus 1.
okay, perfect. If these two conditions satisfied, then we have this series. Converge or diverge?
Then converge.
Okay, then the alternating series converge. Perfect, you did a very good job. Okay, then if we kind of like this one converges, if you can yourself, you can write down all of this from the first section until right now what we have learned, and you can summarize that yourself at home and just recall what we learned and what are the examples. It will help you to memorize all the things we've learned, because we have more tests going on, and I have 2 more tests, I think. Okay, so after that we basically we're done with that series test convergence, and then we're going to do more series expansion like Taylor series and Maclaurin series. Okay, then we're done with the chapter 9. Alright, so next we're going to see the ratio test. What is the ratio test? Ratio test is if the AN series converges absolutely if the limit n goes to infinity an plus 1 over an is less than 1. The next term of the previous term is always decreasing and is less than 1, and we have something in an can't be 0, right? If it is 0, you cannot divide it anymore. So an be a series with the non-zero. So an never be 0. That means this whole thing means an cannot be 0, because an is the denominator. You can't let an be 0. The second one, an diverges if the limit n goes to infinity an plus 1 over an bigger than 1. Okay, if n goes to infinity an plus 1 over an is greater than 1, this diverge. A lot of times you just got n goes to infinity an plus 1 over an, you just got this one equals infinity. A lot of times you got that, and it's bigger than 1, it diverge, because it's keep increasing. The series keep increasing a bigger number, so it diverges. The ratio test, what if the ratio test is inconclusive, which means we cannot make a decision yet. Okay, if it equals 1, an plus 1 over an, if this equals 1, this we can't make any decision. Okay, it's inconclusive, we cannot make a conclusion. For example, n goes to 1 to infinity if it's 1 over n. While you test this one, the limit n goes to infinity 1 over n plus 1 over 1 over n, this equals 1. Oh, this one diverge. Okay. For another one, n from 1 to infinity 1 over n squared. Oh, you check the limit, n goes to infinity 1 over n plus 1 squared over 1 over n squared. You check this one equals 1, and this one converges. Well, it's not because of this one converge, because we know this one diverge. We know this one converge because p series p equals 1, this p equals 2. Both of them have ratio equals 1. Okay, so the ratio test will fail if the ratio equals 1. So we have to use another test. Okay, if the ratio next term of the previous term equals 1, then we cannot make a conclusion. If it's less than 1, it converges absolutely. If it's bigger than 1, it diverges. Okay, so that's the ratio test. I think I can look at the proof next class, but I want to look at some example first. Let's look at some examples. The previous one, just take the example we got. N from 1 to infinity, 1 over n squared n factorial. The one we just did like 10 minutes ago. What we did before, we compare the 1 over n factorial with 1 over n squared. We compare these two. Sometimes you don't know which one you compare with. You say, oh, where did you get the 1 over n squared? How do you know this one is bigger than? Sometimes you just don't know that. And you know this, if I give you that, oh yes, I know that. Now this one converges, this one converges. But what if you cannot find the comparison, another series to compare with? So what you need to do, we can use the ratio test for this one. Limit n goes to infinity, an plus 1 over an. Well, this one equals limit n goes to infinity, 1 over n plus 1 factorial over 1 over n factorial. So the limit n goes to infinity, 1 over n plus 1 factorial multiplied by n factorial over 1. Keep changing flip. Then the n factorial and plus factorial cancel out, and what you got remained. So I want to ask a student to tell me, Zhijian, what do you think what this is? Yeah. So what you simplify everything, what you got in the end. Okay, Matthew, what do you think? I will ask another student. Matthew?
Would this one converge to 0?
Yeah, so this one equals, to simplify this equals what? 1 over what?
Be 1 over n factorial, wouldn't it?
Okay, so let's just say that n factorial is n times n minus 1 times n minus 2 times continual 3 times 2 times 1. That's n factorial. N plus 1 factorial is n plus 1 times n minus 1 times n minus 2 times 3 times 2 times 1. Now, Matthew, could you tell me what that is?
It'd just be 1 second. It'd just be 1 over n plus 1.
Yeah, 1 over n plus 1, perfect. So this one equals 0 and less than 1. So the ratio test, we got the number is less than 1. We got the series converges. Absolutely. But there's no negative 1 to power n, so it converges absolutely. Everything is positive, so it converges, absolutely converges, for sure. So you can just say converges, or converges absolutely fine. Okay. Let's say this one converges. Okay, we will continue tomorrow, not this one, right? But tomorrow is homework review class. Okay, so we're going to review the homework tomorrow, and this is for all for today, and we're going to continue to finish this section next Monday. Right. Tomorrow we're going to look at the homework 6 or 7. All right. Thank you very much. Okay. Have a nice day.